Hello, Professor Sargent here with you again. We know that if you multiply 0 times something, that the result will be 0. The zero factor property, which is written up at the top there, tells us that this kind of goes both ways. If the product is 0, one of the factors had to be 0. We're going to use this to solve a variety of equations. The first one already being written up there. It's already in a factored form set equal to 0. So we have this. That turns the equation into two separate linear equations. Subtract 5 from both sides in the first one, and add 9 to both sides in the second one. The solution set then is set -5, 9. Now, if we had multiplied out what we had on the left-hand side to begin with using FOIL, combine those like terms in the middle, and we would have had that equation to solve. That is a degree 2 polynomial, also known as a quadratic polynomial. And we can use this approach, factoring. Sometimes we'll have to think about factoring completely to solve a large number of quadratic equations. But take notice that we had to have the factoring set equal to 0 to begin with. Okay, here's our next one. And we see right off the bat that we do not have factorization, let alone set equal to 0. Let's set it equal to 0 first. By subtracting the 26R and the 24. If you happen to know a trial and error approach that gives you the exact correct factorization here, that's fine, but let's use the AC method followed by grouping. A is 5, and C is -24. So A times C is -120. For a moment, ignoring that we have a negative. Factor pairs of 120. Don't ever forget 1 times the number itself. 2 will go into 120, 60 times. 3 will go into 120, 40 times. 4 will go in there 30 times. 5 will go in there 24 times. 6 will go in 20 times. 7 will not work. 8 will go in 15 times. 9 will not go into 120. 10 will go in 12 times. And when you make this list of factor pairs, I'm always listing these one with a smaller absolute value on the left. And that's going to go up slowly, but look how fast that went down. The only other thing to try would be 11 between the 10 and the 12. And 11 does not go into 120. Now, since it was negative, we need different signs. We also need the pair of numbers besides multiplying to -120 to add up to -26. To add numbers with different signs and get a negative result, that means the one with the larger absolute value will be negative. Well, 1 plus negative 120 would be negative 19. Negative 119. We want a negative 26. 2 plus negative 60 will give us a negative 58. Not this. 3 plus negative 40 will give us a negative 37. Not this. We're getting closer. And in fact, 4 plus negative 30 will give us negative 26. So we are going to use the 4 plus negative 30 to split up that middle term of negative 26 so that we don't have to worry about factoring out a negative greatest common factor from our second group. I'm going to put the negative 30 first. From our first group, 5 goes into 30, and the lowest power of r there is 1. We can factor out a greatest common factor from the first group of 5r. And the other factor then would be r minus 6. If we've picked the correct pair, then on that second group, when we factor out the greatest common factor for that second group, we should see that r minus 6 showing up again. And 4 goes into 24. We cannot factor anything about r out because the last term does not have an r attached to that. No power of that. So factor out 4. Notice how I'm writing the plus in between there. And we are left with r minus 6. R minus 6 is a common factor to both groups. So one more factoring there, r minus 6 in parentheses times the quantity in parentheses 5r plus 4 is now equal to 0. And that looks like the first question. Apply the zero factor property. The two factors are equal to 0. And again, now we have two linear equations. Add 6 to both sides in the first one. On the second one, subtract 4. But then we still have one more step where we have to divide by 5. So our solution set here is negative 4/5, comma, 6. In our third example, we do have this already set equal to 0. However, we're not looking at a quadratic. We're not looking at a degree 2 polynomial equaling 0. It's a degree 3 polynomial, i.e. a cubic polynomial. However, although we can't factor a number out of 5, 11, and 2 other than 1, we can factor out x to the first. We could go ahead right now and apply the zero factor property here. X is equal to 0, or 5x squared plus 11x plus 2 is equal to 0. And then we have more factoring to do on this part. A times c is 10. It's positive because the 5 and the 2 were positive. So we're looking for two numbers with the same sign. To add up to a positive 11, they'd have to be both positive. And although there's one more factor pair here, positive 1 times positive 10 gives us the positive 10 that a times c is equal to. And when you add positive 1 plus positive 10, you get the positive 11. So let's split up the middle term using those two numbers, a 1x and a 10x. From the first group, factor out x. And normally I wouldn't have written that 1 in front of that, but when you factor out or divide both terms by x, we're going to have 5x plus 1. And on our second group, we can factor out only a 2. And our other factor for that group is, again, 5x plus 1. So 5x plus 1 is common to both of those groups. And looking at what that had been multiplied to on the previous line, we have the other factor is x plus 2. So again, now it's like we're back to where we were with the first question. Set each factor equal to 0. We already had a solution that x equals 0. On this one, if we subtract 2, we'll next have x equals negative 2. And on the last one, subtract 1, and then divide by 5. And we see that negative 1/5 is also a solution. So our solution set here is negative 2, negative 1/5, and 0 with commas in between there. For our next one, there are two special things going on, one more special than the other. The first one I'm going to act like I don't know about. We need to get this equal to 0. I'm going to add 8w to both sides and subtract 16 so that we have this equal to 0. Remember, the first thing that you should look for when you are factoring is the greatest common factor. And if you have a negative lead coefficient, you have a negative greatest common factor. Now, there's no number that goes into 1, 8, and 16 besides 1 itself. We also can't factor out something about some power of w because the last term does not have 1. But we can factor out a negative 1 as our negative greatest common factor. Notice that the negative 1 does not have w, and so that does not give us anything about a solution. And in fact, if you like, you can divide both sides by that constant factor. And 0 divided by negative 1 is still going to be 0. E times c here, here's where I'm going to also, for a moment, pretend like I don't know about the second special thing, but I'm going to take a little more time about that in just a bit. A times c, we have 1w squared positive times a positive 16 for a positive 16 for what a times c is. We need the same signs again, but those two numbers also have to add up to negative 8s, so they have to be both negative. This pair would add up to negative 17, not negative 8s. This pair would add up to negative 10, not negative 8s. 3 does not go into 16, but 4 does, 4 times, and negative 4 plus negative 4 is equal to negative 8. So applying the factoring by grouping here, on the first group we can factor out w, and the other factor of that group is w minus 4. Once again, we're presented with a lead coefficient on that second group that is negative. We can factor out a negative 4. And the other factor of that group will be W minus 4 as well. So we get W minus 4 from what was common to both groups. It was getting multiplied to a W and a minus 4. Since those two factors are the same, we only get one solution to this. W is equal to 4, or writing it as a solution set, we have that. But once this had been factored out, the -1, we could have said, wait a minute, W squared, that's something being squared. And 16, that's something being squared. And furthermore, what we have in between here is we have what is being squared here times what is being squared here doubled. 2 times W times 4 is 8W. That would have given us W minus 4 times itself more quickly, or W minus 4, that quantity squared. There's a formula both for multiplication in one direction and for factoring in another direction. The square of a binomial would equal this. You might say, well, wait a minute. That had a minus and that had a plus. Well, -4 squared is also equal to 16. For a fifth one, we do already have that equal to 0. Remember that we need to factor completely, so we can factor out 4 from both terms on the left-hand side. Because that does not have a y in it, that will not contribute anything to these solutions. In fact, you can divide that out. If there was a variable in that, you should not do that. But here, the only factor contributing solutions to the equation is the y squared minus 4. And again, for a moment, I'm going to pretend like there's something special that I don't know. Got a 1 in front of y. It's positive. So a times c is 1 times -4. So -4. We're going to need different signs. For a moment, ignoring that, the only way that we could use counting numbers to get a product of 4 would be 1 and 4 or 2 and 2. They need to be different signs, but this time there is no y to the first term. In other words, y to the first has a coefficient of 0. And so our pair that will work is a -2 and a +2. Remember, we can actually make this easier when you have a lead coefficient of 1 instead of going through the grouping. We're about to see those same two numbers show back up in the parentheses. We've got a y minus 2 and a y plus 2 showing up again, the -2 and the +2. So setting each factor equal to 0, subtract 2 in the first one, add 2 in the second one, and our solution set is -2, 2. That can be abbreviated because we have negatives of each other with a plus-minus sign. Our solution set is +(-2). this could have been made even easier by recognizing that this is a difference of two squares. Difference of two squares, not the same as a binomial squared. When you factor a difference of two squares, you get the a plus b factor and the a minus b factor. In this case, what was being squared in the first term, our a, that was y, and what was being squared in the second term was 2. That's our b. So we could have much more quickly factored that as y plus 2 in parentheses, y minus 2 in parentheses. And when you set each factor equal to 0, well, those are the same two factors we had a moment ago. So you would still get positive negative 2. Remember that you should look for a greatest common factor at the beginning. We already have this equal to 0. Okay, we already have this equal to 0. Look for a greatest common factor. 3 goes into 15, and our lowest power of x is 1. You don't have to worry about the fact that there's no constant term, because when we factor out 3x, we already have two linear equations when we break that up using the zero factor property. On the first one, that's a 3 times the x, so divide both sides by 3, and you have that x is equal to 0. Subtract 5 on the second one, and we have negative 5. So our solution set is negative 5 comma 0 with those curly Q braces around it. On this last one, it is irrelevant that we see the left-hand side is factored. It is not equal to 0 on the right-hand side. There are infinitely many ways that we can multiply two things and get 1, like 2 times 1/2, 3 times 1/3, 4 times 1/4, or negative 1 times negative 1, and I could keep this list going on and on and on and on. Whereas if we had that equal to 0, the zero factor property is telling us if the product of two factors is 0, then one of the factors has to be 0. So we have to multiply this out, unfortunately. We could use FOIL, or we could use that same binomial squared formula I was talking about previously. In the middle, we're going to have the x and the 2 multiplied, and then doubled. And at the end, the 2 is getting squared. 2 times x times 2 is 4x. 2 squared is 4. To get that equal to 0, subtract 1 from both sides. A times c, we've got a positive 1 times a positive 3, which is 3. And there's only one factor pair, 1 and 3. If they're both positive, they'll add up to the positive 4. Again, because that's a 1x squared, we do not need to go through all of the stuff with splitting up the middle term and doing grouping. The two numbers show back up in the parentheses. So applying the zero factor property and solving those two linear equations, subtract 1 here, subtract 3 here. Our solution set is negative 3 comma negative 1. I did not do this on the previous questions, but we could have done this for any. We could have plugged things back in to do a check. Negative 3 plus 2 is negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus 2 is positive 1. So we've got positive 1 times positive 1 is positive 1. So those do check. That's all I've got for now. Hope that's helped. See you in the next one. Stay safe and healthy.